Hey folks, welcome out there. You are here with me on Mathline. Be there, but also get on those phones, all right? Hey, I'm Ernie Roberts. I'm your host for this afternoon. And I'm just saying, hey, give us some calls. We're going to have some fun today on the show. We are glad you're with us today. 844-686-2378. How many times I say that number? But we want to hear from you, all right? So give us a call. Some of you I know are on fall break this week. A lot of you are going to be on fall break next week. But you know, we're here Monday through Thursday, live here to take care of those who are still without fall break time yet. We're here to help you out, okay? So give us a call. That number is easy, 844-686-2378. We'd love to hear from you. You make the show rock when you call in. We've got an operator waiting for you today. Let them have a good time also, okay? We'll talk to you soon, all right? Speaking of talking, speaking of problems, speaking of math, let's check out our problem of the day. Ooh, this one's had a lot of activity on Facebook today. It says, what is the sum of the expressions 1.2 times 5.4, I'm going decimal on us, okay, or 1 2/10 times 5 4/10, and 3 6/10 times 1 2/10. So that, there's a couple of things that are telling me here. It says, oh, no calculator. Ooh, well, we're really going to work, aren't we? So let's get into this thing. Let's see where it's going to go. We're going to work it the long way, and then I want to show you a shortcut. I don't know if any of our Facebook folks figured out the shortcut or not, and I hope they didn't cheat on the no calculator part, but we're going to take a look at it. There, like I said, there's one kind of long way, and there's one that, man, if you saw it, it comes out really nice and quick and painless. So that's what I want us to see. Sometimes there are alternative ways that you don't think about, but when you get them, you go like, oh yeah, that's so easy. So let's talk about this. First of all, it says, what is the sum? So we've got to have a plus in here. We just have multiplication and multiplication here. So we got two expressions, numerical expressions here. We're going to take 1 2/10 times 5 4/10, as we said. And then we're going to add, on the other side, we're going to say 3 6/10 times 1 2/10. And what we're going to do, order of operations looks like an appropriate thing here. Many of you are saying, yeah, go order of operations. That's what we need to do. They're just decimals, aren't they? No calculator, all right? So off to the side here, what I'm going to do, or down here below, how about it there? We're going to take 5 4/10 times 1 2/10. And notice I put the 1 2/10 underneath because that looks like a lot easier way. It's much easier to multiply by 1 than it is to reverse it and go maybe by 4 and 5. I say a lot easier. For a lot of us it is. And we're going to multiply that. And also over here we're going to take and say 3 6/10 and 1 2/10. Now, my friends, what we want to make sure is that we do pay attention to our decimals in the end, all right? Because there are going to be two decimal places here, which is going to be nice when we put the result together. So keep in mind, order of operations says you multiply first. So let's do some quick multiplication over here. How about it? You got 4 times 2 on the tip of your tongue? Of course we do. How about it? It's going to give us 8. 5 times 2 gives us 10. So far, so good. Let's put another, let's go multiply by the 1 here. We're going to put a little space there with a 0. Put our 4 here and our 5 right there. And where are we going to go with this? We're going to add them. And we're going to get, notice I went ahead and stuffed the decimal because I said we're going to count 2 places, all right? So there's your first result right there. Okay, well, that took a little bit of time, didn't it? Especially since they let you use a calculator. Now, let's go with the next part here. How about it? 6 times 2, you get a 2. We get a, we've got to put a 1 up here, and that's going to give us 72. That part looked easy. And we're going to take times 1. Well, that's very easy. We'll put our 36. Be sure to put a little space there or a 0, whatever works for you. Now, let's piece some stuff together. I'm getting, and I'm going to put that decimal right there because it's the same story that we did over here, isn't it? So we're going to add 4 32/100ths. Well, it's kind of nice, sort of. I think it is. We put this together, and it looks like if we line them up, I'm going to put right down here, bring it over here, and we're going to get a 0, which is nice. Carry that 1, I'm seeing 8, and I'm seeing 10 staying where it is. So it looks like 10 8/10 is our answer that we're looking for. The following people on Facebook: Kimberly, Margie, Mark, Ethan, and Rhonda all did very well on that. Now, let me go with another approach. Remember I said that's kind of a long way, isn't it? So, but it involves us doing our multiplications and it's legitimate. That's what you think of. Taking care of what? The multiplication first, and then we did our addition, order of operations. Now, I'm going to go back to the beginning problem here. I'm going to play with this just a little bit. I'm going to put 1 2/10 times 5.4. There you go. And then I'm going to come back. It's the same problem, isn't it? But I'm going to switch a little bit. I'm going to move the 1.2 in front. You're going to say, what is that about, Ernie? Really nothing. It's called the commutative property. We can move things around within the multiplication part here, all right? But what I want us to see is we have, oh my goodness, we have an application of our friend the distributive property. I have a GCF right here of 1 2/10 that I can pull out. And then what I can do is take these two numbers that are left over. Hey, some of you thought, oh, well, that would be like an X and a Y. It probably would be. But what are we going to do? Because it's connected by an addition symbol here. We brought the 1.2 out by multiplication. Now we've got to write what's left behind. So say goodbye to these guys. And you have, aha, those two added together. Now, why did I choose that? Why did I say that's going to make it easier? Because if you add those two together, it comes out to be, oh my goodness, 9. So we are at 1 2/10 times 9. Because remember where we're going to go. We're going to go parentheses first, right? We're going to finish those. Now we got 9, and you're still going to get 10 8/10. I think that's easier if you see the catch there, the trick. Do you always have tricks like that? No. But if you see a problem like that and you see something in common, think about it. Can I pull it out? And in this case, you certainly could, and let your distributive property make things a lot easier for you. It took a lot less time to do this one than it did that one, right? So there you go. Now, what are we going to do today? We want some calls, all right? We want to hear from you guys. Give us calls, 844-686-2378. We've shown you a kind of little shortcut way to look at some problems and a different way alternatives looking. And I'm going to go back to yesterday's problem of the day. You said, boy, you like to do that a lot, don't you, Ernie? Well, especially when I see done on Facebook, and we have some of our folks really get into these problem of the days on Facebook. And this one was done by a young man named Ethan, who's up in Rogersville area. Ethan, shout out to you, and glad that you're back with us, sending in answers to our problems of the day, and a very bright young man up there. And he showed me a little bit of a different, well, it was a different approach I wouldn't have thought of. But it works, and it works nicely. So I'm going to share it with you guys, all right? So, and while we're doing that, give us some calls. And be patient with me, all right? I want to get through this one with the way we did it, and after that, we will be glad to take care of any calls that are coming through. But go ahead and get in line. We are going to still distribute. Ethan said we're going to distribute first, so I said we'll distribute. Remember what we talked about this a little bit in that problem of the day, and we've got 10n. Gary was with me yesterday when we worked through this thing, and we say a minus 3, life is good. And over here, we get 6n minus, looks like 20. Don't have him here to correct me, but I'm going to look real quick. I think we're in good shape, all right? Now, Ethan did the same thing we did there, all right? And then he put his like terms together. He said 10n plus 2, because that's basically the only like term we got, all right? And that's equal to 6n minus 20 on the other side of things here. So checking that out, you say, well, it looks like what you did yesterday, Ernie, on problem of the day. But Ethan took it one step further. He noticed that each of these numbers is divisible by 2. And I thought, now that's pretty cool because it makes the problem less intimidating to me. So we're going to have 5n divide everything by 2 plus 1 equaling to 3n minus, are you ready for this one? Are we good? How about it? Looks like it's going to be minus 10. And all of a sudden these numbers are smaller, and some of us like smaller numbers, okay? Some people like the big ones. You know, you can get either way. You're going to get the same answer, by the way. So then he subtracted the 3n from both sides, which is pretty straightforward. And by the way, what do we call it when we divide everything by 2 all the way across through there? It's called the division property of equality, and it basically transformed this into a much simpler problem, all right? So if you find a GCF, you can deal with it, just like we did with that 1.2. Boy, what a difference that made, 1 2/10, pulling it out, and then leaving things to add together. But I digress a little bit. Let's finish the problem. How about it? We got 2n plus a 1, and that is equal to negative 10 over here. Say goodbye to those 3n's for sure. Now we're going to subtract 1, And look where we're going. We're going to have 2n left. We're going to have a negative 1. And you know what's going to happen? The same answer we got yesterday, our n when we divide by 2, put that equals there, is equal to a negative 5 and a half, 5 and 5/10, 5.5, however you want to look at it. And it is a negative there. So Ethan, hey, thank you for that alternative solution to there. I always like to see things that are worked out differently, and I've said in a lot of cases, not every problem has 2 ways to work it, but most of them you can find some different ways to work out of it. Love thinking out of the box. Good job on that. And the rest of you that called in yesterday and checked in, we had a lot of conversation about whether it's 5.5 or negative 5.5. I'm going with the negative 5.5 again today. We got it on the show yesterday. Got the same thing using Ethan's method. We're going to go with that. Time to check it? We checked it yesterday, all right? Well, let's get some calls. That's what we're in here for today. Do we have any phone calls yet, guys? I'm hearing the ringing out there. I'm hoping we're getting through it, okay? All right. Well, great. While we're at it, let me just remind you, I mentioned Facebook. Let's talk about it in just a second. We want you to like us, love us. And what I really find is exciting now is we're getting more and more people to share us. Because what that does, it spreads us all over the place. It spreads us in your friends, your neighborhoods, and gives them a chance to have fun with these problems, just like many of you are doing. So www.facebook.com/Mathline Online. Now, if you want to see the problem of the day worked out, we'll take you to YouTube anytime, all right? And you can watch it there. And we stream the shows now with it, as we're going right now, we're streaming. And again, that YouTube thing, it will be, you subscribe to it there at www.youtube.com and work it from there. But right now, Facebook is a big deal. We like that. We like you on Twitter also. But keep us going there, and we will be happy to hear from you in that respect. You can also submit problems on Facebook to us through our email too. So all those good things, we love to hear from you. And I understand we do have a problem waiting for me, and I hope it's not a problem person, but a problem of work to work out here. So welcome to Mathline. Who am I talking with this afternoon?
You are talking with Peyton.
Peyton, good to hear from you again. And what kind of problem have you got for me today?
Graph the equation y equals x squared minus 4x plus 3.
Okay, so we're going to do a graph type situation as what sounds like you've got us going. So repeat that equation for me again so I can write it down here.
All right.
Y
graph
equals?
the equation y equals x squared minus 4x plus 3.
Okay, all right. Well, we'll work through this little thing. It kind of takes a lot of space up, doesn't it, there? But folks, while we're working on that, give us a call, 844-686-2378. Peyton, not going to try to cut you short, but I appreciate we hear from you from time to time, and you always have some good problems for us. So thank you for calling in today. And what we want to do here is, figure out where do we start. So a lot of that business comes from looking for what we call the vertex. Is your problem asking for a vertex by any chance? Looking for a vertex point, maybe? If not,
yes.
We're still going to go there because that's how we're going to start this thing. And what we got going here, what we need to do is we'll take x equals the opposite of our b over 2a. It's a nice little formula to find x. And you say, like, Ernie, what in the world are you talking about? Well, what we're talking about here is let's put in the opposite of b. You say, well, what's a and what's this b? And this problem right here, a is equal to 1, b equals negative 4, and c equals 3. Now, that's your quadratic game, all right? You remember that, Peyton? I say you probably do since you're doing these things here. So a good way to get started here is to pick up what is this value. And the opposite of a negative 4, which is what b is, by the way, is going to give us a positive. And underneath that, we've got 2 and we've got a 1, so we're going to have a 2 times 1, which is real easy. So we've got x equaling to 2, and I'm going to put 2 right in the middle since we're going to call that our vertex, all right? Now, where are we going to go with that? You say, well, we're going to put it in here and see what it gives us, all right? Formula-wise, we're going to pick up the x squared, and I'm about to run out of room here, but we're going to put in 2 squared minus 4 times 2, and we're going to add 3 to that. And that's going to come out pretty nice. It's really going to come out because 2 squared gives us 4, right? Minus looks like an 8, and then we're going to add 3. So I'm figuring this is going to give us, it sounds like is a negative 1? We're going to find out. I think that's where it's going to go, to negative 1. Now, we'll graph these points here in just a second, all right? Now, what I like to do is let's work backwards a little bit. Pick up a couple of more points if you're having to graph this from scratch, all right? And by the way, that x equals 2 is going to be our axis of symmetry, all right? So that's important. That's the axis of symmetry. So we know the middle of the graph is going to go vertical, and it's going to go right through that line. So x equals 2 is our axis of symmetry. And I want to go back with 1. Why 1? Because it's real easy, all right? Easy numbers. We put 1 squared, minus 4 times 1 plus 3. I think it's going to give us a 0 there, Peyton. And then 0 is easier. We're going to get a 3. Now, my friend, why did I choose those 3 points? Because I want to do the other side the same way. I want to pick up 3 and 4. And because you have a parabola here, you've heard me use that word, right? And the parabola means what's going on to the left is going on to the right. And I'm going to go with 0 and 3 for my values there. And we're going to plot these things pretty quickly here. How about 2, negative 1? I've got 1, 0. And I've got 0, 3. I know those are going to work, okay? See what's happening? Now, to the right, I have the points at what? 3, 0. There we go. And over 4 and up 3. And this makes for a nice, pretty parabola, okay? And by the way, remember I said about the axis of symmetry? There it is, that line that goes right down there vertically. And the vertex, right there it is. That's where it bottoms out, right there at 2, negative 1. And we call that a minimum. I said bottoms out, but it's a minimum point, okay? It's as low as it'll go. Does that work for you?
Yes.
All right. Hey, thanks for calling in. That's a good problem there. And if we have time toward the end of the show, I might go ahead and run it on the graphing calculator, but I understand we've got another caller waiting. So, Peyton, thank you for getting us started today, all right? And I understand I have another caller waiting. Welcome to Mathline. Who am I talking with this afternoon? Alyssa, so good to hear from you. How are you doing today? And where you? Yeah, good. And where are you calling from again, so our viewers know? Because Alyssa's one of our favorites here. She calls in from time to time. We like to hear from her also. Where are you calling from? Hey, yeah, we. All right. Well, and so glad to have you with us again. What kind of problem have you got for me this afternoon? What do you got for me?
15.9.
Oh, we're decimaling, huh? All right. I got it. 15 and 9/10, 15.9. What else are we going to do? Excuse me.
Divided by 0.8.
Try that again with me. Divided by?
Divided by 0.8.
0.8. Does it look like that? Is that what we're reading?
Yeah.
Okay. So what I'm going to do is I'm going to put the 8/10 or 0.8 as we call it to the outside, and I'm going to put 15 and 9/10 on the inside. Does that make sense so far?
Yeah.
Because this number, the way you've read it to me anyway, this number is going to go on the outside, this number is going to go on the inside. So we're ready to work this one out. So let's do some maneuvering. We don't like decimals. Well, we like them. You like them better in fractions, I bet, right?
Yeah.
Yeah. Well, what we're going to do, we're going to move this decimal over so it kind of disappears, all right? And what we did there, my friends, and those who are watching, and you too, Alyssa, we just multiplied by 10. That's how we shift it in one place. But you know, if we do it outside, guess where else we have to do it? We have to do it on the number here. So we're going to kick that right over to the right of the 9. You see what I did? You got it?
Yeah.
All right. So now it looks more like I'm taking 8 and I'm going to divide it into 159. So basically the decimal disappeared because we had one place on both of these. So that's really what the new problem looks like. So at this point, we're going to play it out and see where it goes, all right? I'm going to tell you something. It's probably not going to come out even, and I'm going to leave it with, we may leave it at decimal point. Since we started out with one decimal place, we may just take it to round off to a one decimal place. But what I was going to say is, if that had been 160, you know what would happen if it said 160? We'll divide 8 into that evenly. This is going to be really, really close to what looked like was going to be 20. So you know what I'm thinking? I'm like Gary Petco when he's on the show with me. We estimate a little bit. So let's see how close we are. I say it's going to be real close to 20. The answer is. Let's divide 8 into 15. It goes one time. I bet you can tell me what 1 times 8 is. What you got?
8.
8. There we go. So we're going to subtract, and my goodness, it's very close to 80 there. It's as close as you can get without hitting it. We're at 79. So Alyssa, I'm going full throttle here. I'm going for 9. You know why I'm going to go for 9? Because 9 times 8 gives me, you got that one, or I'll tell you. Which way you want to go on that? It's big, isn't it?
That's 72.
72. Now we've got a 7. Oh my goodness. And we're going to, if we bring down some zeros, eventually this thing will finish out. Okay? It will eventually come out even. It's going to take a while. But I said maybe we wouldn't round off the nearest 10th. But we could eventually, folks, we could make that come out even. But it would take a while. Let's see what's going to happen. I'd say 8 into 70. Well, I know it's not going to be 72, so let's bring it down by 1. How about an 8? 8 times 8 would give us 64. Okay, and look what's happening. I'm still dropping off there with 6. Phew, we can keep this thing, like I said, we keep this thing running. But at this point, it looks like it's going to be, you know what, I'm seeing 6 over 8. And I'm just going to jump ahead with you on this. We're going to be 7 there, right? 7 times 8, how about it? 56. And Alyssa, I promised you it would come out even eventually. There we go. 8 into 40, 5 times. Wow, that last 0 coming all the way down there. And there is your decimal answer. As I said, it's really, really close to 20, isn't it? But there's your final value. Does that work for you?
Yeah, thanks.
Good, and so good to hear from you. Glad to have you call today. All right, and understand I have another caller waiting in the wings. Welcome to Mathline this afternoon. Who am I talking with?
Dylan Parsley.
How are you doing today?
Good.
And where are you calling us from? Oh, I'm doing fine. It's always good to have people call in. It makes it a lot more fun for me and everybody else. What kind of math problem have you got for me this afternoon?
Okay, so if a store has 55 bottles of dish soap and sells 25, and each bottle of dish soap is $5, but comes with a $2.50 coupon off that they can use on the bottle, then and they pay an original price $1 per bottle of dish soap, how much profit do they make?
All right, so let's go back here. So you bought the 55 bottles for what? 55 for $1 each?
Yes.
Okay, so that's basically the cost you've got into it, right?
Yes.
And you're going to sell what, 25?
Yes.
And they're going at what, $2.50 or $5? At $5 each.
$5 each, yes.
Okay, all right. So we got not $25, but 25 bottles times 5. But you're going to give a what? A 50% discount? It sounds like $2.50 off.
Yes.
All right. So what I'm going to do, since you're doing that for every bottle, I'm going to go ahead and say we're going to take that 5 minus $2.50. Does that make sense?
Yes.
Because basically, what are you paying? You're paying $2.50 for each of those, right?
Yes.
So you have now put in $55. That was your cost, but you've made some money. You've made basically 25 times $2.50 per bottle, right?
Yes.
So what we're going to do is we're going to see, in this case, we want to figure this hopefully is higher because you're looking for profit, right?
Yes.
And so we got a little, I'm going to hit the calculator on this, but I am thinking it's going to be, I always get myself in trouble when I say these things, but I think it's going to be $62.50. Let's see if that comes out there. And we'll take it times 2.5. I'm right, $62.50. That's because I knew 25 times 25. That worked out really nice. I just had to play with the decimal. We've had a lot of decimal play today. So let's see what we've got here. We got $62.50 minus, you said you're spending $55, right?
Yes.
And I think we take that and subtract, it should be $7.50, which is a little profit. I don't know if it was worth your work on that. Let's see, and we're going to we'll trust me on that. 62 minus 55 will give us 7, and we have 50 cents chump change. Does that work for you?
Yes.
Does it
now,
make sense?
if we took that answer, times it by 5, and then divide that by 11, which would equal x times y.
Okay, now I'm sorry, I lost you on part of it there. Come back again on me there. You were going to take the 750 and what are you going to do with it?
Take that minus 11.
Take this minus 11?
Yes. And then that is what equals x. And then take y, which is 25, and times that.
Okay, I'm going to ask you if you'll just hang on the line. We'll finish working this. We're out of time on the air. Folks, thanks for tuning in. Thanks to our callers, and we will see you again next time.